Let's talk about two-dimensional kinematics. In lecture, we've already talked about the four equations of kinematics in one dimension, and the equations of kinematics in two dimensions are pretty much the same, with a couple of small changes. The most noticeable change is we take the position variable x and transform it into the variable r to encapsulate all motion in both the x and the y direction. We also marked all of our vector variables with little vector hats. These small changes don't change the fundamental meaning of the equations of motion, but they do require you to pay attention to three important rules. Rule number one, and I cannot stress this enough, you cannot combine motion in the x hat and the y hat directions. Rule number two, read rule number one again. Rule number three, don't forget to check your units, always. Let's do an example. Bob starts at the position 1 meter in the x direction, 2 meters in the y direction, and then moves with the average velocity of 1 meter per second in the x direction and 1 meter per second in the y direction for 5 seconds. What's his final position? This is a clear case of using equation number 2. So here's Bob at his starting position. To find out the change in his position, we have to multiply the average velocity by the time it takes for him to move. Multiplying a vector by a scalar is easy. You just multiply each component by the scalar. So the average velocity times the time is 5 meters in the x direction and 5 meters in the y direction. You can add those two vectors together and come up with the final position for Bob, which is 6 in the x direction and 7 in the y direction. Writing out vector equations might seem daunting, but there is a method to this madness. Writing out our vector equations explicitly allows us to collect our vector components and our scalar components together. Writing out the equation like this gives us the ability to collate all the information that we know about the problem into a single equation. And then if we need to, we can take this equation and separate it into an x equation and a y equation, and we won't get confused as to which terms belong to which equation. This allows us to solve the top and the bottom separately while following rule number 1.